Guys, the winner for the previous video's contest was Sri Parmeshwari Harvester Supramani, and he asked me if we modify the winding of a mini DC motor and increase the torque and speed. So that is exactly what I'm going to do in this project, or to be specific, I'm going to try to do in this project. So you can see this power supply, 15 volts, 3 amperes. It's only 15 volts, 3 amperes supply, so you don't feel a thing. Okay, so guys, the question for today is what will happen if the number of turns per pole on the armature of the motor are not identical? So anyways guys, I searched it a lot on YouTube to see if anyone had conducted a similar experiment, that is converting a 220 volts permanent magnet DC motor to 12 volts DC motor. But since I couldn't find it, so I thought about experimenting it myself to see if it works or not. So let's try it. Note that the experiment is really dangerous, so don't conduct it at home. And guys, I got this permanent magnet motor from a mini blender. Okay, so guys, the motor is completely ready now. Let's see if it can survive the high current that is going to flow through these springs that are going to feed the brushes. So guys, to power it up, I'm going to use this 12 volts, somewhere around 20 amperes DC supply to run this motor, and there's a great chance that the motor is going to burn out. It is working, but like it is heating up a lot. Super hot. Yeah, actually the current needed is too high, and of course the brushes are not able to feed it to the armature. You see, it is working. All in fumes. The full motor is in fumes. Whoa, the brush is boiling. It's too hot. I think it is going to catch fire. Speed is increasing. I don't know why the speed is increasing. Why is the speed increasing? I don't get it, seriously. Seriously, why the speed is increasing? You can see the speed has gained a lot of speed here. Whoa. Whoa, 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 whoa. Yeah, something bad is going to happen, I'm sure of it. Yeah, the motor is running really fast. The brush is going to... It has come to a stop finally. And that brush part has completely melted, guys. You see, it's completely melted. And on this side, motor is like super hot right now. So yeah guys, there is like a few things that we learned from this experiment is that this motor that I used is a 220 volts DC motor, okay, and I converted into a high current DC motor. So like I came from 220 volts to as low as 12 volts, and I gave like a less number of turns, because of which the resistance reduced and the current automatically increased. And then again I also used 3 times thicker wire, so again the resistance reduced, so it needed more and more high current, and obviously the brushes were not designed to handle that high current. So the result of it was that the motor burned out.
3.70 amps, DC amps.
Hey guys, in this video I'm going to teach you different methods with which you can self-excite universal motors at home. The project was requested by the previous video contest winner Julian. So guys, you will find 4 wires coming out of the universal motor, 1, 2, 3 and 4. 2 of which must be connected to each other and the remaining 2 must be open for connection to run this motor. And guys, you're also going to need this 12 volts to 220 volts inverter or DC to AC converter. So guys, first comes the connection of the bridge rectifier, okay? So what you have to do, you have to connect the AC terminals to any one of the 2 terminals that are left out, meaning not connected. Now the other AC terminal will remain open, and to the DC output terminals this inverter or DC converter will be connected, okay? Mind the positive and negative. Now with that being done, I will use this high capacitance capacitor bank. You can see a single capacitor is rated at 110,000 microfarad at 15 volts DC. Now guys, connect the negative, which is this black one, negative, to this black of the universal motor. Now to the positive, you have to connect the left out wire of the rectifier. Now comes this 5 volts 2 amperes mobile charger. You see, 5 volts 2 amperes. So I have to connect it to the inverter, okay? Connected. Now there are 2 left out pins, black and red, to which I'm going to connect this extension, okay? With red being positive and black being negative, and connecting it accordingly to the capacitor bank, black to black negative, red to red positive. Now all I have to do is start the setup by giving power supply to this motor, and that is going to run this universal motor, and let's see what happens. Because DC motor speed controller, okay, that's the AC side. This is the DC side to which I'm going to connect the terminals of the treadmill motor. Always turn off the supply first. Make sure at the start the speed is at 0. This is the bulb that will be connected to the terminals to which this inverter has been connected. Yeah, this one I will connect afterwards. Okay, let's go. Well, there was some problem in the wiring. Oh, you see, the motor is turned on. Although at present it is showing low battery, but in few moments it should gain like charge, and the low battery light should go away if it is working. It seems like it is working. The light is going. I'm going to give you a close-up. Yeah, you see the low battery light is going away, and the main light is getting brighter and brighter. Somehow the light just turned off. When I'm touching the terminal, then the light of the inverter is glowing brighter. I don't know why is that. You see, it is glowing brighter. Let's connect it permanently to this point. It seems excited, but it is like getting dim and dim and dim and turning off. I think the bulb has got fused. Guys, now what I have done is to one terminal coming out from the universal motor, I have connected the rectifier's terminal, and the other also I have connected the rectifier's terminal, okay? And the output of the rectifier DC is going to feed the inverter, and this 5 volts charger is connected here, that is going to feed this excitation capacitor, which is going to excite the universal motor. So this is another way that I'm going to try. Whoa, it is getting auto excited. Huh? What the hell? I think I'm seeing something here. Oh, the wire is hot. I didn't even like charge the capacitor bank and everything is like smelling over here. I think I should limit the feedback voltage from the capacitor to the universal motor. I think this one should do. Let's try this. Bulb is not glowing, meaning that there is no charge in the capacitor bank. Let's see if it can get self-excited like it did before. Whoa! Yeah! Oh, yes! I seriously did it, guys. Yeah! This is a self-excited universal motor, guys. Self-excited, no battery given, automatically excited. Now this is going to be the third or fourth of my unbelievable inventions. I knew that if I'm going to set a resistor feedback, it is going to work. No excitation not needed. Oh yes. Oh yeah. That inverter is feeding it. You see that it is glowing better and better, and in some time that low battery voltage indication is going to go out, or some of the wire might just get burnt, because at present it is heavily loaded. And this thing is not present on YouTube anywhere on the internet. That's the first, and I'm the one to do it. Oh yeah. Cool. Yeah. Let's measure the voltage. That is only 1 volt charged. Let's measure the voltage across the bulb. Oh, the wire is super hot, guys. This is connected to that. Okay, so I can get the voltage from here. One terminal over here and one over there. Yeah, at present I'm getting somewhere around 5.27 volts. If I go a little bit faster on the treadmill motor, obviously the bulb is going to glow a little more. Would you like me to do that? Say yes. Okay. Yeah, it is working. Let's turn off the lights and then check it out. Let's see how bright it is. Let's turn it off. You see it's turned off and it is still glowing because of the circulating magnetic field. I seriously just love electricity, and there is so much to learn still. Now guys, you all must be thinking that this method is super complicated. Well, the good news is that there is another shortcut, super shortcut, in which you are not going to need any of these. Okay, so for that I'm going to use this 12 volts UPS battery. Next, what you have to do is run this motor with a DC source, not an AC but a DC source. Okay, you can see that it has started running. Initially, when it was running on AC, the residual magnetism was 0 because of changing magnetic poles. The pole which was initially north became south and then again north. So there was 0 residual magnetism. But now that I've fed a DC source to it, the poles have a residual magnetism. Now using that residual magnetism, I am going to self-excite it without any external source. This is a bulb, you see, incandescent bulb. Okay, let's connect its terminals. Now let's turn the supply on and see if it gets self-excited. Okay. You see that it is self-excited now. Cool, right? If you have a DC source, you can attain that residual magnetism like which is present in car alternators. And when you have done that, then you can get it self-excited, but not if it is continuously running on AC source. No other wire given, okay? Super bright bulb. Cool. Let's measure the generated current. Okay. .70 amps. DC amps. Haha. Cool, right?